Hey guys, this is a response video on how to set different step heights for characters of the same size. So we can see the two red characters chasing the yellow character, and the lighter red one can only step over the shorter obstacles, and the darker red one can step over both the short and tall obstacles. So let's take a closer look at how we do this. Okay, the first thing we'll look at is the yellow character, which is the standard pawn size, and then we have the two red characters, which are slightly larger, but they have the same dimensions, but they can each step over different obstacles. So that means that they have their own recast. So we see one for the yellow character, and then we see one for the light red character, and one for the dark red character. Now, normally, since they're the same size, they should be using the same recast, but we're able to give them two separate ones, and we'll get into how we do that in a little bit. But let's take a look at the yellow recast first. I'll turn it on, and we can see that he can go over the short obstacles, but he has to avoid the tall obstacles. And let's go ahead and take a look at the first red one. He's very similar to the yellow one in that he can follow him over the short obstacles, but he also has to avoid the tall obstacles. And let's take a look at the dark red one, and he can just go over all the obstacles no matter what. And the reason why is because he has a different agent max step height. So let's go ahead and take a closer look at this value here. Okay, to understand agent max step height, we'll start off with a single character and a single recast. And as for the obstacles, the shorter ones are set to a height of 50, and the taller ones are set to a height of 100. And the default max step height is 35. So let's go ahead and set it to 50, and we can see that now it's able to calculate over the shorter obstacles. And if we set it to 100, now it's able to calculate over the taller obstacles. So let's go ahead and play the game and see if that works. And we'll notice that he gets stuck on the obstacles. So to understand why, let's go back real quick. Now the reason why that didn't work is because this value only pertains to the NavMesh itself. It's the value that the NavMesh uses to calculate a path over the obstacle, but it doesn't take into account the personal limitations of the character itself. So to take a look at those, we need to look at his blueprint. Now here on his blueprint, if we go to his character movement component and we search for walk, we'll see that the first option is his personal max step height. Now if we set this to 50, he would be able to go over the short obstacles, and if we set it to 100, he would be able to go over the tall obstacles. Now I'm going to set it to 105 because sometimes depending on the shape of the geometry, he needs a little bit of a margin of error. So let's go ahead and compile and save this and check it out in game. Okay, and with his personal max step height set to 100, he's able to get over all of the geometry just fine. But now let's go back and see what happens if we set it to just 50. Okay, and with it set to 50, he can get over the smaller obstacles just fine, but we see that he's still trying to get over the taller obstacles, and he's getting stuck. And that's because, again, the NavMesh is calculating that there is a path over it, but his personal limitation kicks in at the last second when he tries to step up on it, so he's not able to complete that path, even though it exists. Now let's go ahead and go back to the content browser real quick. And just like how there are personal limitations for the character, there are also personal limitations for the geometry itself. So if we click on the geometry and we go to its static mesh and we search for step, we can see this option here, can character step up on, and we can set that to no. Now again, this will result in the same thing where the NavMesh is calculating that a path exists, but then at the last second, this personal limitation of the geometry will prevent the character from stepping up on it, and so he won't be able to complete the path, and again, he'll probably just get stuck. So there are situations where you can make use of this option, but it's not going to help us this time. So let's go ahead and undo that. And now let's go ahead and take a look at another method that we could try, which is to use custom area classes and query filters. Okay, now if you need more help with area classes and query filters, I'll put a separate video down below, but right now we're just going to go through it really quickly to see if it helps with this situation. So we'll start with the area class, and we're not going to do much to it. I just put it to yellow so that we can see it better. And then we'll go to the query filter, and we'll just set the area class, and you can either give it a high travel and entering cost, or you can just click this button here for is excluded, and this essentially just turns it into a null area, but it only affects the character that's filtering for this area class. So let's go ahead and compile and save that. Then we'll go over to the AI controller for the character, and we'll set the filter there. Now here on the AI controller for the character, we'll just search for filter, and we'll select it in this list. And let's go ahead and compile and save that. Now back here in the content browser, I don't want to pull in a bunch of separate nav mods, so I'll just go to the blueprint for the obstacle, and I'll assign them from there. So now we see that all of the obstacles have the nav mod applied to them, and they're only affecting this character because he's filtering for that area class. So let's pull in the other character, and because I temporarily switched him to a different AI controller, he's not going to be affected by these area classes. So let's go ahead and play the game and see what this looks like. Okay, and we can see that the dark red character is going over all of the obstacles, and the light red character is going around them because he's filtering for that area class. Now this isn't a very efficient way of doing this, because we would have to create a bunch of different nav mods, query filters, and area classes for all the different combinations of obstacles and characters. So you might find some miscellaneous use for this, but ideally we want to go back to that first method we were trying, which is Recast multi-agent support. So let's undo all of these nav mods, and we'll try to continue with the other method. Okay, and here on the project settings, I've already set up my 3 agent masks, and if you need help doing this, there's a separate video down below, but let's continue with what we're doing. So I have one for the yellow character, one for the light red character, and one for the dark red character. And after you fill out their values, you would go to their character blueprints, and under their character movement component, you would search for agent and fill out the same values here. And this is how they'll know which recast object to use, because they'll match these values with the ones that you filled in over here. Now, one of the things that we want to look at is that since the light red and the dark red have the same agent radius and agent height, they should use the same recast object. But since we gave them unique step height values, this one is 50 and this one is 100, then they'll create their own unique agent masks, which is just another way of saying that they're different enough to create their own recast object. Okay, now let's take a look at one more thing. We'll go back to a character blueprint real quick. Okay, now back here on the blueprint for the character, we want to make sure that we understand that when we're setting the step height for the nav agent, this is referring to his relationship with the NavMesh and which recast object is calculating his path. So in other words, the nav agent might tell him that the quickest way to his destination is to simply walk up these stairs, if this was how tall each of the steps were. But then his character, if we remember earlier we searched for walk, and under character movement, when we set this step height, this is referring to his physical ability to accomplish what the nav agent suggested to him. So the nav agent might say, go up those stairs that are 100 units tall or whatever, but he might respond by saying, I'm physically incapable of doing that. I can only step this high. So when would you have a disconnect between these two values? Well, it's actually quite common. So if we pull out the character movement component, and if we search for set max step height, we'll see it down here. You can change this during gameplay. So this might be tied into something like his character skills, like agility or acrobatics. It might also be tied into something like over encumbrance for his inventory. And then if we go back and we search for agent again, we'll see that this section is called movement capabilities. So if we come down here and we search for capability, we'll see we can get the struct for this section. So let's pull that out and we'll split the struct, and now we can set these during gameplay as well. So again, if we were to change these, this would alter which recast object is now calculating his paths, and if we change this, this will alter whether or not he's able to climb over the things that this one is suggesting. Okay, so that should be everything that you need to get different characters of the same size to climb over different obstacles. I hope this helped. Please like and subscribe, and I'll see you guys in another video.